Hi folks, this is Karim of our IT Visualizer channel. We will continue our lab, the matrix labs, the video number 136. We have been discussing in the previous video the following while still working with troubleshooting Windows using Microsoft Sysinternals suite. We have seen the different scenarios created by Claude 3.7 Sonnet AI tool. We have seen that these scenarios are very creative, very practical, and actually I have already uh, uh, got a lot of info from these scenarios. Actually very informative. Actually the best answer I have got concerning learning dialogues and explaining topics is from Claude 3.7 Sonnet. And maybe the next AI tool that comes in place, it is Grok, and then I think after that maybe Gemini, and the last one is ChatGPT. So anyway, let's continue with the couple of scenarios also created by Claude 3.7 Sonnet concerning Microsoft Sysinternals suites. We've seen here the case number 19, the runaway website. This is an administrator noticed a server process called jrun.exe called Fusion would periodically max out one CPU core on their servers. Leo, this is similar to our previous case. The administrator used Process Explorer to identify the runaway thread. Leo shows a Process Explorer screenshot highlighting a thread consuming high CPU. So maybe we can open a Process Explorer. So we can see here, this is the CPU usage. We can see here each process and how much CPU it is consuming. So this is good. Let's return to the scenario. Leo at the thread stack revealed that cold fusion component were calling registry enumeration APIs. So I think he is talking about something. This process is accessing the registry. They examined the stack traces showing this DLL and this DLL. What are those components doing? The administrator then used process monitor to see exactly what registry operations were occurring. So what this tool is doing, we need to open the process monitor to see what they are doing exactly. They look at process monitor output showing thousands of reg enum key operations. Okay, that's a numerous number of registry operations. What was it doing? When they checked which registry key was being accessed, they found it was HKLM software macromedia called Fusion current version clients. The Cold Fusion server was storing client variables in the registry, and that key had accumulated tens of thousands of entries. Okay, so this is a program, a server and the client scenario, or a server and the client uh, topology. Okay, so we can see that the problem was that there is a lot of agents stored in this registry key. Okay, so maybe this was the problem. That would definitely cause performance issues. What was the solution? Cold Fusion can store clients variables in different locations. The administrator simply reconfigure it to use cookies instead of registry. They show the Cold Fusion configuration change. A simple configuration change is solved a long-standing performance problem. Leo, exactly. Process Explorer and Process Monitor revealed not just what was happening, but why it was happening. It's like finding out that traffic is uh, 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 backed up not just because there is an incident, but because someone forgot to remove a construction detour sign after construction ended. A traffic is backed up not just because there is an active, but because someone forgot to remove a construction detour sign after construction ended. So this is something called Cold Fusion program. What is Cold Fusion? Maybe this is something we need to know. First of all, let me get this case and ask Grok to explain it in simple terms, just to break it up, because I don't know what is called fusion. Let's try to see if we can simplify it more. We go to Grok and tell him explain this case in layman's terms and create glossary for terminologies so we can know each term and what does it mean exactly. So we can put like this, and let's see how Grok will explain it. We can copy that and ask even Gemini to explain it. And now we can do like that, and then let's see even ChatGPT if it can explain this case. Let's see how Grok will explain that. So here it is. Imagine you are running a busy library website that helps people find books online. The website is managed by a program called Cold Fusion, which runs on your server. Think of the server as the computer that keeps the website going. One day, Maya, the person in charge of the server, noticed that it's working too hard. Especially one part of the server brain, a CPU, is completely maxed out at time. This slows everything down, making the website sluggish for users. Okay, Maya calls in Leo to figure out what's wrong. Leo used a tool called Process Explorer, which is like magnifying glass for the server's activities. He discovered that a specific task called the threads inside the Cold Fusion program, especially jram.txt, is the troublemaker, hogging all of the attention of the CPU core. Digging deeper, Leo looks at a to-do list called the stack trace for that task and see that Cold Fusion is busy talking to the Windows registry, a big filing cabinet where the server stores important setting. Many my wonders what's it's doing in there. So Lee uses another tool, Process Monitor, to spy on exactly what's happening. They found out that Cold Fusion is frankly flipping through the filing cabinet thousands of times, performing an action called reg enum key. This action is like listing every single folder inside a drawer over and over again. It's a huge effort for something that should be simple. They track down the drawer called Diffusion, the exact drawer Qt Fusion obsessed with, a spotted label, so and so. The drawer is stuffed with tens of thousands of little notes called client variables, which keep track of information about the website users, like what they have been doing on the site. Over time, the drawer got so full that every time Cold Fusion tried to check it, the server goes overwhelmed, causing the slowdown Maya notice. Maya says, no wonder things are slow. How do we fix it? Leo explains that Cold Fusion doesn't have to store these user notes in the filing cabinet. Instead, they can switch to using cookies, tiny notes that get handed to each user web browser to carry out information instead. This way, the server doesn't have to dig through the overwhelmed crowded drawer anymore. This make a quick change in Cold Fusion setting, and just like that, the server stops overwhelming itself. The website runs smoothly again. Leo sums up with a great analogy. It's like figuring out why traffic is jammed. You might think it's just an accident, but then you realize someone left an older detour sign up after road work was done. Tools like Process Explorer and Process Monitor didn't just show us the traffic jam, they helped us find and remove that leftover sign. In short, a small tweak turned a runaway website into a well-behaved one, all thanks to some clever detective work. We can see Cold Fusion, a tool used to build and manage websites and web applications quickly. It's the software behind the library website in this story. So this is a tool to build websites. Okay, CPU core وهي seen Process Explorer, a thread, a small job within a program. JRun might have many threads running at once, like different workers handling specific tasks in the library. Stack trace, a list showing what a thread has been working on step by step. It's like a logbook of the thread's recent activities. As you can see here, APIs, rules that let programs talk to each other. Here, Cold Fusion uses API to interact with the registry like a librarian asking the filing cabinet for info. Very, very good. Okay, these two files, DLL, just a moment, guys. So let's continue, guys. Here, these are these DLL files, special files that help Cold Fusion to do extra tasks like managing registry stuff. They are like add-on tools for the librarian. Process monitor. What is reg enum key? A special action that lists all of the subfolders or subkeys in a registry section. It's like flipping through every folder in a drawer to see what's inside. So that's it. Here, this is these two files. They are making reg enum key. They are listing all of the entries in a specific section in the registry. Okay, so this seems to be a very good explanation about the case. So again, if we can return to to the explanation, maybe we can return back again. Here you go. It is saying uh, let me see what is the reg enum. Okay, so it's saying that these two DLL files, the stack, so these two are making thousands of reg enum key operations, listing all of the files in a certain registry or listing all of the subkeys in a certain registry key. Maybe to see the user or the clients or to add new clients maybe. So anyway, this seems to be a good explanation of the case. Let me see if we can have a better explanation maybe from uh, ChatGPT. Let's see that. Uh, okay, the case here is talking about okay. Okay, this seems to be better organized. Cold Fusion was using the register to remember visitors data. Okay, and over time this key got overloaded with 10,000 of entries. Okay, this can be another addition to our explanation. Why it went wrong? Every time the website ran, Cold Fusion cobbed through the giant list of clients entries in the registry, like leading through a massive phone book every single request, causing the CPU to spike. So okay, this seems to be a good one. So this is a good one. Okay, I think also this is a simple explanation. And here is the glossary. Okay. Okay, this is for example registry enumeration API. Windows function like enum key used by program to list or read registry entries. Reg enum key, a registry function that lists the names of subkeys. Okay, so again, I think uh, this explanation is simple enough. If we go to Gemini and try to see his answer again, okay, okay, seems to be much. Okay, he is talking or he is explaining too much. The aha moment. Okay, okay, I think this is overwhelmed explanation. I think the better one is Grok. Then maybe see it's. Let me try to read it simply. Okay, you see. Okay, what's doing? Watching closely. Process might show that the thread was constantly looking through enumerating specific action. Okay, no, this seems not to be a good explanation from my point of view. No, this is not a good thing. Okay, so I think Grok then ChatGPT, they explain it well. So let's go to the other case, excessive ready boost. Here's an interesting case where a laptop became sluggish after waking from sleep with high disk activity for several minutes. I remember Ready Boost. This was, I think, a feature in Windows 7. I don't know if it is already in Windows 10 and 11 or not. To boost the performance by putting a flash and make it as a physical RAM, okay, to be added like a physical RAM. I think this is the ready boost. Let's we can query AI tools to explain the ready boost, but let's see the case first. What did Process Explorer show during the time? The system process was consuming significant CPU, so the system process called system, consuming significant CPU. Looking at its thread revealed a thread starting in RBY boost to sys the ready boost driver. They examine a process thread listing showing the ready boost threads. What's ready boost? Ready boost is a Windows feature that uses flash drivers, okay, like USB sticks or SD card, as a form of memory cache to speed up the system. But in this case, it is causing the slowdown. So this is the explanation. Okay, let's see what process monitor showed. They look at process monitor output showing ready boost activity. After unhinding system process activity in the Process Explorer, it revealed a long sequence of reads from the ReadyBoost cache file on the flash drive. So ReadyBoost was constantly reading from the flash drive. Why not? Why would that slow things down? So why is this? It's like a RAM. In this case, something was wrong with either the ReadyBoost driver or specific flash card being used. And instead of helping performance, it was hurting it. What was the simple solution? Simply removing the ReadyBoost flash card resolved the issue immediately. This was likely a rare bug in the ReadyBoost subsystem or a compatibility issue with that specific flash drive card. It's interesting how a feature designed to improve performance was actually causing a performance problem. Uh, Leo, it happens more often than what you think. That's why troubleshooting with tools that show you exactly what's happening is so valuable. It's like a car that's making noise. You need a look under the hood to see which part is malfunctioning. So let me first we have the system. Here you go. We can see the system has a lot of things inside it. So this is the system, and we can see a lot of sys files uh, under it. We can see the handles, we can see the threads, okay, we can see DLL files. So a lot of things are using this system, or the system has a lot of things running under it. So if you go to the case, I need just to, for my info, to get to perplexity AI, and ask it to uh, make deep research about, so let's continue about ready boost Windows feature. Let's see if it will get us a good research. So set sources for each research. So now we make a deep research. Control C. Let me do like that, and then go to Grok and tell him the same deep search, but go to deep extended search. Okay, and let's see how this will go. And now we can go to complexity. If you go to Grok, so as we can see here, ReadyBoost was introduced in Windows Vista and is available in Windows 10 and 11. So it's still available. This feature is still available. Let's see how this will go. So we can go to here. We have also have deep search. We can do like this. So we can go there and tell him deep search, ReadyBoost feature, and let's see that. everything. So let's see here. Still doing a deep search. It's still searching. Okay, I think I can do that also from Gemini. Let me get bored, and then we can, I think we have deep search here again. So we have experimental, we have deep search, and tell him like this one, and let's see how this will go again. So they are making a lot of research. uh, this is good because they are getting a lot of info. So here is the plan I have put together. Let me know if you need any changes before I start. Okay, let's start search and see. And then we have uh, Grok. uh, Still okay, it's finished already. So I think we can read the first one. Windows Ready Boost, a comprehensive analysis of performance enhancement through external caching. The Windows Ready Boost feature introduced in Vista and maintained through subsequent Windows version represents a unique approach to system performance optimization by leveraging external flash storage devices as supplement cache. This report synthesizes experimental data, architecture analysis, and real-world performance metrics from 7 key sources to evaluate ReadyBoost efficiency across different hardware configurations. It's a good one. Core findings reveal that while ReadyBoost provides measurable improvements in specific I/O bound scenarios, particularly on rational hard disk systems with 4 GB of RAM, its beneficial diminish significantly on modern SS equipment machines. That seems to be right. Benchmark test demonstrates up to 300% faster application restore times post hibernation and 10 seconds reduction in boot sequences. Uh, Though these gains correlate strongly with baseline system specs, the technology interaction with Windows Superfetch creates a hybrid caching system that prioritizes frequently accessed data blocks in flash storage, achieving 4 to 6 milliseconds random read times versus traditional HDD S 10 to 15 minutes. However, competitor analysis suggests diminishing returns in post-2015 hardware environment with only 23% of test systems showing significant performance gain when using 8 GB RAM configuration. So again, we see here that it's saying that uh, because of using SSD hard disks, the using of this feature has diminished or it's not that important anymore. Okay, think I think it was used or it is better to be used with traditional hard disk or rotational hard disks. Okay, and he's talking about 4 gigabyte of RAM. So this it benefits diminish significantly on modern SSD equipment machines. Benchmark tests demonstrate up to 300% faster application restore times post hibernation and 10-second reduction in boot sequences. Okay, and he's saying that when you have uh, a machine with 8 gigabyte of RAM and traditional hard disk, 23% of this system showing significantly statistically significant performance gains. So as the RAM increase, this ready boost feature is not that good. Okay, let's go and see. We have architecture foundation of ready boost. Hybrid caching mechanism. ReadyBoost operates through tight integration with Windows memory management subsystems, creating a three-tier storage hierarchy: primary RAM, ReadyBoost cache, file paging. So these are the three caching places: primary RAM, non-violet, flash 4 to 6 millisecond access, uh, page filing on hard disk 5 to 15 milliseconds, or 0.1 millisecond SSD access. So maybe the SSD is faster than the Ready Boost in this case. Okay, he's saying HD SSD 5 to 15 millisecond, HHD slash 0.1 millisecond. uh, I think no, HHD is 5. No, I think 15. Okay, I think the SSD is faster. The architecture allows Superfetch to maintain cached copies of frequently accessed data on flash media, with Microsoft EMD management service dynamically adjusting cache allocation based on the user usage pattern. The system authorizes small random read operations where flash so and so. Okay, flash requirements. You need to have enforces strict performance for Daddy Boost. You have the Ready Boost using flash 2.5 megabyte 4K random reads, 15 megabyte random writes, IM latency, real world testing reveals in various compliance with some USB drivers exceeding 4 so and so reads but failing write validation due to controller limitation. The registry hack detailed in bypass this check by modifying performance analysis across use cases. Low memory on legacy hardware with this RAM memory. ReadyBoost demonstrates real benefits. Application launches time 18 to 22% reduction in cold starts for office suites. Post hibernation responsiveness 8x or 8 faster application restoration 45 to 5.6 milliseconds. Multitasking 37 reduction HHD thrashing during concurrent app usage. The cache proves particularly effective for metadata heavy operation. NTFF master file table access show 40% latency reduction when cached on USB flash 3. Hard or high memory systems, modern configuration exhibit diminishing returns. So if you have a system of 8 gigabyte of RAM and you have SSD, no statistically significant improvement. In 90% of test cases, HSD 5 to 8% gain if you have a system of 8 gigabyte of RAM. In edge scenarios, malware scans and so on. So gaming 0 FES improvement across 15 testing titles with 2%. So we can see that certain situations Ready Boost is a gain. Okay. Technical implementation details, file system integration. Ready Boost creates an encrypted SFC cache file using so and so. This cache maintains administrators can force cache retention through group policy. Okay, registry modification. Advanced user manipulate these registry settings for custom configuration. These overrides enable Ready Boost on fast USB 3.1 Gen 2 drives that otherwise fail automatic qualification. Comparative analysis. So while 4 gigabyte DDR3 modules achieve 12 gigabyte bandwidth versus so and so, Ready Boost provides cost-effective performance scaling. So here you go, the cost: 4 gigabyte RAM, 8 64 gigabyte Ready Boost cache. So if you need to upgrade, you can put Ready Boost cache and it will be less in cost. 64 gigabyte Ready Boost cache, I think this is a flash. So the flash is less than a real RAM, which seems to be good. Here we can see the subsequent read. This seems to be less. 4K random read, so on. So this seems to be less. Access latency 15 ns. Data shows Ready Boost delivers 80% of RAM upgrade benefits for HDD systems at 30% cost. Okay, that's good. This seems to be a good one. So you can put a flash and you can get 80% of RAM benefits with 30% cost. What seems to be good versus SSD. So this is the one. This is for the traditional hard disk. As for the SSD, we can see it will drop actually. Where is the SSD? So in SSD, modern NVRAM drives negate ready boost value proposition. So we can see here there this seems to be good at read, and we can see application launch. This 21 seconds here is 1.8 and 1.6. Boot time 45 seconds. Here we have 22 seconds, 18 seconds. So this seems to be not working with new types of hard disk. SD adoption reduced ready boost performance delta to 5% in most metrics. Best configuration, optimal device selection, 1 to 1.5 physical RAM, 1.5 by physical RAM, 4 gigabyte of RAM, 6 gigabyte of cache, interface USB U3, this is the USB flash, with USB support, media, LSC, MLC, TLC, NAND, file system NTFS with 4K. This is the optimal solution you can use Ready Boost with, or the best situation to use Ready Boost with. Performance tuning, disable writing cache in device manager, select MTFS MFT reservation to 25%, allocate 25% drive space to Ready Boost, enable write back buffer via registry. Limitations and workarounds, file size limit 4 gigabyte cache on FAT32 device systems, write endurance, okay, trim, compatibility issues, encrypted rabbit locker conflicts with SFC cache encryption, so you should not use BitLocker on it. RAID arrays incompatible with storage spaces, XFAT format, no support for journaling requirements. Future relevance in modern computing. With SSD adoption exceeding 78% in new PCs, Ready Boost utility concentrates on legacy system, so I think it's not that good anymore. Okay, legacy system maintenance, government, education sectors with HSD-based infrastructure, emergency performance patches, temporary boost for aging hardware, specialized workloads, database indexing on write optimized flash. Microsoft quiet hours feature, disabling background caching during active use, and SSD optimization, optimized superfetch algorithm further reduce Ready Boost impact in Windows 10 and 11 environments. Okay, so it's not working anymore. Conclusion, Ready Boost remains a valuable performance enhancement tool for specific legacy configuration, particularly 5400 RPM HDD systems with 4 GB of RAM. Its hybrid caching architecture delivers measurable improvements in I/O bound scenarios, 15 to 40% latency reduction, though these gains diminish rapidly with modern hardware. For competitor user SSD upgrades, even SATA models provide more consistent performance benefits at similar price points. System administrators maintain older infrastructure should prioritize Ready Boost deployment on frequently hibernated machines and multi-user workstation, while home user SSD can safely deprioritize this feature. So you cannot use it because if you have a laptop with a SSD, so this is not a good feature anymore. Future Windows irritations could benefit from extending Ready Boost architecture to leverage NVMe attach Optima or 3D X-Point Media for persistent memory applications. So even though it seems to be more technical, but it seems to give us a glance about it. If we go to Grok, Ready Boost is a caching feature developed by Microsoft, first introduced in Windows 7, Windows Vista in 2007, and including subsequent versions, including Windows 7, 8, 10, and reportedly Windows 11. It aims to enhance system performance by using external flash driver memory, such as a USB flash drive, SD cards, or compact flashes, as a cache for frequently accessed data. This guide provides an in-depth exploration of Ready Boost, uh, covering its functionality, requirement, effectiveness, setup process, and relevance in modern computing environments. So I need to just uh, close this one. How I can close it from here? So we can go like this. So I think we can go little by bit. ReadyBoost is a software component that leverages the faster random read speeds of NAND flash memory to cache data typically stored on slower hard disk drive (HDD). Unlike traditional RAM, which is volatile and loses data when powered off, ReadyBoost uses a non-volatile flash memory to store a cache that supplements the system's memory management. It works in conjunction with Superfetch or Sysman in later Windows versions, a disk cache management technology that preloads frequently used files into memory for quicker access. The core idea is that the flash memory have much lower seek time than less than 1 millisecond compared to mechanical HDD, allowing faster retrieval of small random data reads. ReadyBoost does not replace the paging file, a portion of the hard disk used as a virtual memory, but acts as a cache. Okay, if data is not found in the ReadyBoost cache, the system fallbacks to the HDD. Okay, so the paging file is important. As you can see, there is three types of caching: one in the memory, one in the ReadyBoost, the second one, and the last is in the paging file on the hard disk. So how ReadyBoost work? We can see here ReadyBoost operates by creating cache SFC on the root directory of the compatible flash drive. This file driver interprets all read and write operations to the local hard disk, copying written data into the cache file. Then, when the system needs to read the data, it first checks the ReadyBoost cache, which can be faster than accessing HDD for small random reads. Key technical aspects include data compression and encryption, superfetch. Cache size is to 250 megabytes. Okay, Windows reporting okay, while maximum varies upon so and so up to Windows 7 file system support system. Okay, system device for ReadyBoost. Both system and flash drive must meet specific criteria. Operating system, that's it. In Windows is debated. So though availability in Windows 11 version 2.22 H2 is debated. So maybe it will not work with a newer version of Windows 11. Storage type ReadyBoost is disabled if the system drive is an SSD. As SSD offer read speeds comparable to or faster than flash drive. So this will not work with SSD. It will be disabled. Most effective on systems with limited RAM, 512 megabyte to 1 gigabyte to 4 gigabyte as Perplexity have said. The service Superfetch or Sysman must be running. So to use this feature, we have these two things to be running. Device requirement at least 256 megabyte with 1 gigabyte minimum free space recommended, maximum 32 gigabyte per device. Performance access time of 1 millisecond or less, at least 2.5 megabyte throughput for 4K. So okay, we can see that compatible, not supported on portable media drives like mobile phones or cameras. So this should be a flash drive. Recommendations: a flash memory to a system RAM ratio of 1 to 1 or to 2.5 to 1 for optimal performance. Okay, for example, a system 1 gigabyte of RAM should use 1 to 2.5 gigabyte of flash memory for ReadyBoost. Okay, this is good one. Okay, set up ReadyBoost. Here you can see the steps. ReadyBoost. Okay, safely remove. Performance impact. Okay, the ReadyBoost depends upon the system hardware and task performance. Benchmarks and user reports provide insight to its impact. Benchmarks and the tech 2007, no performance difference. This is 2007. I think this is not a recent study. Scenarios where ReadyBoost helps low memory systems. This was said by Perplexity, but up to 4 gigabyte of RAM. HD based systems, that's correct. Frequently small reads, like opening application, browsing, or switching between programs, benefit from faster caching access. scenario where ready boost is ineffective. SSD based systems, high RAM systems, CPU intensive tasks like coding or video encoding or gaming depend on processor speed, not disk access. Sequential read and writes, HD are faster for large sequential data transfer, which ready boost does not handle. User experience. Some users report noticeable improvements on older laptops with low RAM. Okay, we can see that. Effectiveness in modern Windows version. ReadyBoost has diminished with advancement in hardware. Okay, this seems to be good. Windows 10. The ReadyBoost offers a nice performance enhancement. On high tech, we can see this is not noticeable. Windows 11 ReadyBoost is still available, but its status in Windows version 2.22H2 is controversial. Some sources claim it was removed, while others provide guides on enabling it. User report ReadyBoost missing on SSD-based systems or high RAM configuration with method like this. ReadyBoost is not enabled because this computer is fast enough that ReadyBoost is unlikely to provide additional benefits, so it will not be available in SSD, and this was not stated with Perplexity. Monitoring boost, you can monitor ReadyBoost performance using Windows Performance Monitor. Limitation and consideration, device wear. Flash drivers have a finite number of writing cycle, but ReadyBoost usage is estimated to last over 10 years under typical conditions. Okay, compatibility not supported in portable medias like phone or cameras or Windows Server editions. Historical issues. Early Vista versions had a bug where the cache wasn't recognized after sleep mode. Data security, always use safely remove hardware to prevent data loss. Alternatives to ReadyBoost, add more memory, switch to SSD, optimize system. So, okay, a couple of info was added to our search, but Perplexity seems to have much info. ReadyBoost, if we can see here, okay, this is some things, how ReadyBoost works. Caching, fast random, ready cache, super fetch. Seems to be not organized. I see a lot of data, but not organized in a way to make it easy to read. Okay, historical, so and so, requirement and compatibility. Okay, speed, file system, OS support. It's not typically used on Windows Server. The SD Windows will disable ReadyBoost, so this is confirmed. Optimal ratio, we have seen this. In summary, we'll have you will want a relative fast USB with a few gigabytes of free space formatted NTFS or when plug it Windows SSP can be enabled, so on. So well, I can't see the same performance impact and benchmarks. 10 to 15%. Examples of ReadyBoost performance gains on low RAM system. Again, this should be on low RAM scenario HSD with limited RAM. We can see a couple of things. I think Perplexity seems to have a good info. Okay, ready cache, ReadyBoost versus upgrading versus an SSD. This is a good topic here. ReadyBoost essential a workaround for when adding RAM or upgrading to SSD is not possible or cost effective. It's useful to compare those approach. Okay, so this is good when you don't need to add RAM. Okay, because of its cost, or upgrade to SSD during or according to its cost. But I think the SSD is less nowadays. But let's continue. CD boost, file cache, and install memory, upgrade to SSD. Okay, comparison. So we see ready boost, typical performance, use case study. Okay, idle, upgrade to SSD. Okay, I think this table suggests ready boost was a clever feature to squeeze extra performance for an existing machine, but it cannot match the benefits of actual hardware upgrades. The most useful scenarios where adding RAM or SSD is impossible, or it isn't possible due to cost, technical skill, or device limitation. Okay, that seems to be good. Okay, limitations: already boost is not effective. Okay, no benefit with SSD. Okay, minimal benefit with ample RAM. If you have a lot of RAM, this will not work. Workloads that do not heat the disk, CPU heavy calculations, or GPU intensive gaming. Diminishing returns with large cache. Boost caches are capped to 32 GB per device on newer Windows. Extremely large flash cache beyond what your workload needs wouldn't further improve performance. Okay, flash drive wear and tear. ReadyBoost will continuously write and erase data on the flash drive during normal operation. Flash memory has finite write and erase cycles, while ReadyBoost in normal use shouldn't kill a quality drive too quickly. It uses where leaving and only caches portion of data. A cheap USB stick left in 24/7 for ReadyBoost could experience wear over time. So this has a limit. Some users have reported USB becoming unusable after long-term ReadyBoost use. Uh, though it is accidental, it's sometimes uh, to keep in mind. If you plan to dedicate a flash drive to ReadyBoost, use a decent quality one. Okay, consumes USB or SD port. This is a minor logistic limitation. Leaving ReadyBoost attached will copy the port full time, the USB port. On disk, with many ports, there is no issue. But on a laptop with few ports, sacrificing one for ReadyBoost might not be worth it. Okay, or worthwhile. Compatibility quirks. Some devices, even if it's fast, might not detected as ReadyBoost capable due to driver issues or how they report their speed. Okay, Freddy Boost, not cure at all. Okay, use cases and best practice. Or the laptops and notebooks, limited RAM, slow HDD. The scope where RAM slots were full or RAM is expensive. Later, where opening PC is not feasible. So if you need that, you need to use high USB flash drive, uh, USB 3.0. Dedicate the driver if you can. Uh, Format with exFAT for large cache. Keep the cache drive plugged in. Monitor performance. Do not expect miracles. Use realistic expectations. Boost can make a slow PC feel snappier, but it wouldn't turn a 10-year-old machine into a high-end one. Okay, disable when no longer needed. Current relevance of ReadyBoost in 2015. With the state source, ReadyBoost has moved from center stage to fairly niche feature. When it is adopted into Windows Vista timeframe, a large portion of PCs stood to benefit from it. Many had low RAM and HD. Today, the landscape is very different. Okay, so this seems to be good. Storage, Ready Boost still exists. Niche, alternative solutions. So we can see this is the explanation. If we go to Gemini, we will see this is the Ready Boost again. Okay, introduction. Okay, it seems to have okay, I think we have a lot of things here about this Ready Boost feature. So let's go and continue with the case 21, the stuttering laptop Blu-ray player. The next case involves a laptop whose optical drive would occasionally spin up even with no disk inserted. Whose optical driver would occasionally spin up even with no disk inserted. Okay, later when watching Blu-ray movies, playback would stutter about 10 minutes in. Okay, the user first used process monitor to identify what was causing the drive to activate. They filter process monitor to show only access to DVD drive. First, they filter process monitor to only show events related to DVD. You need to have a process monitor filter at path begins with G includes. Okay, so that's it. Something called WMI so and so is trying to access the drive during playback. What's that? Is a WMI provider host. It's a service that provides information about the system to management application. In this case, something was using MPI to check the optical drive. Could that cause the shuttering? To confirm it was the cause, the user temporarily disabled the Windows Management and Instrument Service, and playback worked perfectly without shuttering. So something was using WMI to repeatedly check the optical drive, causing the stutters. Exactly. Next step was to find out what was triggering those WMI queries. They show the steps to enable WMI trace login in Event Viewer. When I traced login event viewer, they could see exactly what was happening. The trace showed a client process requesting information about the CD-ROM drivers with this query. Okay, and which process was making the query? Process revealed something called so related to Bluetooth hardware on the laptop. They look at the process explorer properties for this process. Since the user wasn't using Bluetooth, the stable example fixed the problem completely. So Bluetooth device was repeatedly checking the optical drive during through WMI, causing the shattering playback. Exactly, process monitor helped identify what was happening, and then process explorer event tracing helped trace it back to the root cause. It's like finding out that your TV reception getting fuzzy because someone is using a microwave. Two seemingly unrelated things that actually interfere with each other. So this seems to be a strange case. So he's talking about a case involves a laptop whose optical drive was occasionally spins up even though no disk inserted. Later, when watching Blu-ray movies, playback was shutter about 10 minutes in. Okay, so this seems that the DVD or optical or DVD drive spins even though there is no DVD in it. And when he play Blu-ray movies, it jumps out 10 minutes in. So he is saying that when he used process monitor, he saw a process, this process is trying to access the Blu-ray during the playback. Okay, and uh, when he disabled it, it was working perfectly. So they need to know why the WMI is accessing the playback. So they make a trace for the WMI events in the event viewer. They have WMI trace, and then they say that there is a program called Blow Soil so and so is related to Bluetooth trying to access it. Strange, but let me have something here. I will take this and try to ask Grok to explain it because I think it needs further explanation. If we go further and get this shuttering case, copy, and then we go to Grok. Here, tell him where is Grok, and let's close this one, and let's tell him like this, and let's first go to, I need to have it to be explain. Okay, let's go, this is one, and we will copy it. Okay, and then we will go and do like that, and then we'll get the case. So here you go, we have copy it, and then we have it pasted here, and then let's see what it will do. So we can close the process explorer. So this is the case of a Blu-ray. Then we have case 22, the company 15-minute logs on. So let's see. Imagine you have a laptop with a slot where you can pop in DVD or Blu-ray disc to watch movies or install stuff. The slot is called the optical drive. Now, Maya, the person in this case, noticed something weird. Laptop optical drive kept making noise and spinning up even when there is no disk inside. It's like the drive was randomly waking up and checking for something to do, which was pretty annoying. Then, when she tried to watch a Blu ray movie, it would play fine for about 10 minutes, but after that, the movie started to shutter, like it was pausing or skipping, ruining her viewing experience. So, this is what we mean by shutter. To figure out what was going, Maya turned into a detective. She used a tool called Process Monitor, which is like a super detailed logbook that shows everything your computer is doing in real time. Since this logbook can get overwhelming with tons of info, Maya zoomed in on just the stuff related to her DVD drive. She did by filtering Process Monitor, which is like telling it, hey, only show me what's happening on the optical drive, ignoring everything else. By looking at this filtered info, Maya could see what was spooking her drive and making it spin up when it shouldn't. It might be something simple like a program checking if a disk was inserted, or it could be a sneaky background task, or worse, like a virus. For the Blu ray shuttering, it's possible some other program was interrupting the movie, like someone tapping you on the shoulder while you are trying to focus. Or maybe the laptop didn't have enough power to keep the movie running smoothly because other things were hogging its attention. So, how Maya fixed it? Here is what she could try. Stopping the driver from checking all disk at the time. There is a feature called autoplay that automatically looks for disk. Turn it off might stop the random spinning. Find and shut down troublemakers. Using Process Monitor or other tool like Task Manager, she could spot programs messing up with the drive and stop them. Check for bad software. Running a virus scan could roll out malware causing the issue. Keep things updated. Make sure that the drivers, the software that helps it to talk to the laptop, and Blu-ray player program are up to date. That could fix glitches. Clean up a dusty disk or a drive might cause shuttering, so giving them a wipe could help. Give the movie some space. Closing other programs while watching could free up the laptop energy to focus on the Blu-ray. By playing detective with Process Monitor and tackling these possible causes, Maya could stop her drive from acting up and enjoy her movies without those annoying stutters. So, even though this was not the case, okay, but he gave us other clues, okay, to what may be the cause. But the cause was a program that was interfering with the Blu-ray itself, and it was related to the Bluetooth. Okay, so I think we can stop at this case 22, or we can take it. Let's see if we can take it. The company 15 minutes login. The company has a curious issue where users with specific image took 15 minutes to log in, while users with a standard image logged in quickly. Maybe this is the user image profile. Let's use different. What was causing the delay? The support team had been investigating for months without success. Finally, someone used Process Monitor to boot's login feature to capture the entire login sequence. We have seen the boot logging feature. After capturing a boot log, they examined the process tree in the Process Monitor and found something surprising. They show the process tree from the boot log pointing to the screen. Look at that. There is a McAfee installation script running during every login with a /force install parameter. But this uh, with other users is working perfectly. Extra motivation. A login script was reinstalling a McAfee program during every user login took about 4 minutes to complete. But why was it only affecting specifically this image? The script was configured in group policy that only applied to the OU units containing the specialty PC. It was supposed to have been removed months earlier, affecting the specialty image. It was configured to, so this group policy was applied only to certain users with certain image, supposed to be removed. So a forgotten GPU was causing 15 minutes login for all those users. Yes, once they removed the script from the GPU, logins was immediately fast again. Process Monitor boot logging solved the months long mystery in just hours. Extremely powerful feature for troubleshooting boot and login issues. Think of it like a security camera that can record what happens even before the security guard arrives for duty. This also needs to be explained a little bit. Let me again take Grok to explain this topic. Okay, let's see that. So the last one, we will copy that and do like this, and let's go there and take the case and explain it again. So this seems okay. We will copy that, and then we will try, well, I will try to do like this and see the last one. So let's see what is the answer of Grok. If we go further and see the case, imagine you're a company where some employees can log in into their computer super fast, like in seconds, while others are stuck waiting for 15 whole minutes just to get started. It's like some people are zooming through the front door while others are stuck in a long, slow line. That's exactly what was happening in this case. Employees with standard image on their computers logged in quickly, but those with specific image was left twiddling their thumbs. So, what's an image? Think of it like a pre-packed kit for a computer, kind of like a lunchbox with the operating system like Windows and all software already tucked in. Okay, standard image. So he's talking about a standard image for the Windows standard image, or like a backup, or like an image or a Windows system image. Okay, the company used these kits to set up lots of computers the same way. Most computer got the basic lunchbox. Okay, so this seems to be fine. It worked fine, but some got a fancier one with extra stuff. Okay, so now this is clear. For months, the tech support was stumped that properly checked the obvious things like if the internet was slow or if the computers were old, but nothing explained why only some people had this crazy delay. Finally, someone has a clever idea. They use a tool called Process Monitor with its boot logging feature to figure out what's going on. Picture Process Monitor as a super noisy detective that watch every move your computer makes, what file is opening and what setting is checked, everything. The boot logging part is like telling that detective to start writing down every single thing the computer does from the moment it wakes up, including someone tries to log in. It's like getting a minute by minute diary of the computer's routine. So with this diary in hand, the tech team could see exactly what's happening during those 15 minutes. Maybe the computer was trying to start a program that was taking forever, or it was waiting for something that wasn't ready, like a printer that was not plugged in. Or perhaps there is a company rule called a group policy or a little automatic program, a startup script that was tripping things up. The case doesn't say exactly what they found, it said. But once they had this detailed record, they could pinpoint the problem and fix it, maybe by tweaking a setting, updating something, or getting rid of whatever was slowing things down. In the end, the smart tool helped so. So we can see here that this uh, there was a group policy applied to certain Windows images in the domain. Okay, so they are targeting certain custom Windows images in their domain, not the standard Windows images. So this is what was the case. They are targeting with the group policy the specialty PC. Okay, some PC they are through WMI. I think they are targeting certain PCs with certain Windows images or a special Windows image. So this is it. They have already uh, uh, deleted this group policy. So the script or the login script was not applied to them anymore. So this solved the case. So we'll stop at case 23, the hanging PayPal emails. Hope this video informative for you all, and thank you all for viewing. Thank you so much.